The large ball is also coated with graphite paint. Both balls are uncharged. The small ball presses down hard onto the large ball, charging the PVC pipe negative. I do not bring the pipe into contact with the large ball. We can see that the small ball somehow obtained a negative charge. The charged pipe pushes some of the free electrons in the graphite coating towards the rear of the ball. Some of them ends up on the small ball. The small ball is now repelled by the negatively charged side of the large ball, it being closer to the small ball. All of this was made possible by the conduction electrons in the graphite coating being able to move about on the ball. Here I am again charging the system up. The conduction electrons flow onto my skin in this case, leaving the system with a resultant positive charge. Now I am having some fun discharging the system with a ground wire connected to earth. The pendulum electroscope is transporting electrons from the ground wire to the large ball, thereby ridding the ball of its positive charge. This demonstration gives one the idea that electric charge is something real, something that moves about between and in materials. The positively charged balls pull some conduction electrons into the tip of the probe on the end of the wire. The pendulum electroscope is now attracted by the probe and repelled by the large ball towards the right. Conduction electrons is also drawn onto the small ball once it joins up with the probe. It is now attracted by the large ball and repelled by the probe towards the left. The extra conduction electrons on the small ball is now pulled onto the large ball. This reduces the amount of positive charge on the large ball and leaves the small ball with a resultant positive charge. The small ball is now repelled back towards the probe and the process is repeated. Discharging the pendulum electroscopes by connecting them to earth. Charging the pipe negative. The electroscope is now charging up. Charges up. It has the same charge as the pipe. What can we learn from this? The ball is sticking to the pipe. This means that the pipe is charged, but not high enough to transfer electrons to the electroscope. The charge concentration on the pipe is also not uniform, since it only succeeds in some regions to charge the electroscope. We can also conclude that the graphite coating is not naturally conductive. Only when it comes near a region of the pipe where the charge concentration is high enough does it accept electrons from the pipe. One electrical quantity that measures this charge concentration is the voltage. So we can say that the graphite coating only becomes conductive above a certain voltage. That is, a certain minimum amount of work needs to be done before the material in the coating frees some of its electrons. Once this happens, the material accepts additional electrons on its surface. We say it has become conductive. It is a good idea to warm the apparatus up before experimenting with it. I use a wooden box with a space heater for this purpose. This discourages the water molecules from condensating on the material, which would otherwise cause it to lose some charge. On this particular day, the humidity was quite high, around 60%. The room temperature is around 24 degrees Celsius, and the tube's temperature have been raised by about 9 degrees to 33 degrees Celsius. I did also put everything else in the heat box. All of the equipment was heated up for this clip. Charging the pipe negative. The ball in front is covered with gold foil. It is not charging up. The graphite coated ball charges up relatively easily. The gold ball do not want to accept charge from the pipe, which is not at all what one would expect, since gold is one of the best conductors of electrical charge. A close-up of the ball covered with gold foil. Note that a tiny bit of foil is sticking out at the top next to the thread on the right. One would think that because the electrons are repelling each other, that they would avoid the sharp point, since that forces them closer together. But that is not what happens. One should rather think of it like a balloon deflating. The air rushes towards the spout. Similarly, the electrons on the rest of the ball pushes some electrons onto the sharp region. Here the electrons do not fly off into the air though. The surface of the ball is bombarded by air molecules due to the pressure and temperature of the atmosphere. Specifically, the oxygen molecules in the air pick off electrons from the pointy region and are changed into negative ions. This is called corona discharge. The oxygen ions are then repelled away from the ball. The relative humidity was quite high on the Mandela Memorial Day, since it have been raining cats and dogs, so I decided to experiment inside of the heat box. Inside of the box the humidity was quite a bit lower after heating up the apparatus. I've used a nail clipper to get rid of the bit of foil that was sticking out. It keeps the charge now. Charging up the graphite ball. They both stay charged now. The graphite ball comes into contact with the metal rod and is discharged in the process.